It's Mrs. Thompson. We're in section 3.3 now, and we are going to now separate parallel and perpendicular lines, and this particular section is going to deal with parallel lines. So let's look at the very first postulate. Again, you need to add this to your electronic notebook. And basically what it is, it's the converse of the corresponding angles postulate. So if you remember from our previous lesson about corresponding angles, we said if you have two lines that are parallel, then their corresponding angles are equal or congruent. And so now we're going to do the converse. Remember, converse is flipping the hypothesis with the conclusion. So now we're going to start with the conclusion, okay? And if you have a pair of corresponding angles that are congruent, then what we can determine is that the lines must be parallel. Now, if they're not congruent, then clearly they're not parallel. So that's what the converse is all about. And so in example 1, we're going to use this particular postulate to make some assumptions and to prove some things that they're asking us to prove. Here are the directions. Use the converse of the corresponding angles postulate and the given information to show that line L is parallel to line M. And what they gave us in section or in letter A is that angle 1 is congruent to angle 5. Okay, this is given. And so if you look positionally where angle 1 and angle 5 are located, they are in the corresponding angles. So we can then say angle 1 and angle 5 are corresponding angles. Okay? Therefore, angle or line L is parallel to line M because of the converse of the corresponding angles postulate. And so we're doing a little bit of justification. It might seem elementary to write everything out, but it's really putting your logic on paper and going step by step, explaining why this has to be true. Now let's take a look at letter B. They gave us that angle 4, its measure is 2x plus 10. Angle 8, its measure is 3x minus 55, and they told us what x equals. Now, you may want to go ahead and grab your calculator. It would behoove you to go ahead, since you already know what x is, and let's figure out what the measure of angle 4 is. So in your calculator, let's do 2 times 65 plus 10. And when you do 2 times 65 plus 10, you get 140 degrees. Okay, so angle 4 is 140 degrees. Now we're going to do the same thing over here. We're going to do 3 times 65 minus 55. So in your calculator, practice doing that, and you will get, oh, it's also 140 degrees. So when they are the same measure, that means they are congruent angles, and we can say angle 4 is congruent to angle 8 because they have the same measure. They're in the corresponding angles position, and so they are corresponding angles, which means L has to be parallel to M because of the converse of the corresponding angles postulate. Do you see how simple that is? It's really, you're proving either with your math that the angles are equal, or they've given you the angles, and you're just using some very basic logic to prove that these lines are parallel. And it makes it a lot easier if we can actually say, well, the converse of the corresponding angles postulate is the reason why these lines have to be parallel. All right, if you guys have any particular questions, write those down and bring those to class tomorrow. Thanks for listening.